everyone and welcome to Mathematics with Usman. I am back today with another video and this time it is about the limits of accuracy. In GCSE syllabus there are two main objectives that we have to attain. Number one, students, we must be able to give appropriate upper and lower bounds for a given data to a specified accuracy. This can be the measurement of length or the measurement of the times or the measurement of the masses. Number two, students obtain appropriate upper and the lower bounds to solutions of simple problems. These problems can be the calculations of the parameters or the calculations of the areas of the figures. Students, remember, all the measurements are approximate. They are given to their nearest specific units. It can be kilogram, it can be milligram, it can be millimeters or the centimeters. Let's dig deep into this topic with the practical example. In the given figure, a weighing scale is given which is calibrated to the nearest kilogram. A baby is having a mass of 7 kg. What could be the lowest mass of the baby that will be rounded off to 7? And we are agreed that it must be 6.5 because any number less than 6.5 would have been rounded off to 6. So the lowest possible weight a baby could have is 6.5 and we call this weight the lower bound. Now, what's the heaviest of the baby weight could be such that it is rounded down to 7? And student, here would be agreed to me, it is 7.49999 recurring. And 7.499 with the repetition, it is approximately equals to 7.5. So the heaviest of the baby weight would be 7.5 and we call this value the upper bound limit. Now the original value of the mass of the baby would be somewhere in between 6.5 and 7.5. This limit is called the limits of accuracy. There is another way to give the mass of the student in the form of inequality. The mass of the baby is greater than or equal to 6.5 and less than 7.5. Students, if you find it difficult to realize, there is a very simple method. And let's explore it. Half the degree of accuracy specified. Number 2, add it to rounded number to get the upper bound and subtract it from a rounded number to get the lower bound. Let's see the baby example in another way. The mass of the baby was written to the nearest kilogram, means 1 kilogram. So half the degree of this accuracy 1 kilogram. So half of 1 will be equal to 0.5. Now what was the rounded number? That was 7. So add this 0.5 to 7 to get the upper bound and subtract this 0.5 from 7 to get the lower bound. So this is how you can find the limits of accuracy. Now let's apply these concepts to the need situation problem. What we have is question number 1 and it says give upper and the lower bounds of each of the following numbers as specified. What we are given in part 1? Find the upper and lower bounds of 4.6 to two significant figures. So you can see 6 is the second significant figure and it is at the 10th position. So it means degree of accuracy is 1 by 10, 0.1. So first step is make the half of 0.1, it is 0.05. Second step is find the upper bound by adding this number to the rounded number which is 4.6. And to find the lower bound, we will subtract 0.05 from 4.6. Now what I want you to do is stop the video and give a go to this part. Welcome back. Students, see the degree of accuracy is 5.5 centimeter, so make it half, that is 2.5. To find the upper bound, you will add this number and to find the lower bound you will subtract this number. Let's do one more example, which is example number 3. 72,000 and correct to one significant figure. But we are having 72,000. So correct to one significant figure, it becomes 70,000. And since the one significant figure is at the 10th thousand position, so what we will do, we will take 10,000 and make it half. So it is 5,000. Now add it to 70,000 to get the upper bound and subtract it from 70,000 to get the lower bound. Let's do question number 2. The flash from a camera is timed at 0.04 seconds. So time is given 0.004 seconds. And we have to write it correct to 1 by 1000. So 0.001 seconds. Calculate the upper and the lower bound. So students, what we are going to do, we will half the degree of accuracy, that is 1 by 1000 means 0.001 divided by 2, what we are getting 0.005. Now add it in 0.004 in order to get the upper bound and subtract it in order to get the lower bound. Okay, and this brings us to the end of today's tutorial. I hope it has some value to your mathematical concepts. Keep watching Mathematics with Usman. Like and subscribe to my YouTube channel. See you. Goodbye.